Here we want to factor x to the fourth plus 1/2 plus 1 over 16x to the fourth. So this is definitely not as obvious to recognize that it's a perfect square trinomial, but we'll start to break it down and recognize that it is. So we're going to be using the a squared plus 2ab plus b squared form to factor to our perfect square. So we have x to the fourth can be rewritten as x squared squared. And now I'm going to go ahead and jump to this last term here and recognize that 1 over 16x to the fourth can be rewritten as 1 over 4x squared squared. Okay, so now we just need to confirm that the middle term is 2 times ab. So let's go ahead and write out 2 times a, which is x squared, times our b, which is 1/4 x squared. Well, the x squared over x squared cancels, and then I have 2 over 4, which is 1/2. So the middle term here really does simplify to 1 over 2. So this does have the form of a perfect square trinomial, and so we know that it's going to factor to quantity a plus b, quantity x squared plus 1 over 4x squared, all in parentheses, squared. Now, before we move on to the next example, I also want to point out that another way we could have thought about this last term is we could have thought about the last term originally as 1/16 x to the negative 4. And the main idea is that we want to be able to recognize that something like this could be a perfect square trinomial and thus factor to something like this. And it might be easier to sort of recognize if we, instead of thinking about the last term with the x to the fourth in the denominator, rewrite it as x to the negative 4. And so we'll see how to work with something like this in the next example. In this example, we want to factor 1/4 y to the 6th plus 1/2 plus 1/4 y to the negative 6. So here, similar to that last example, except that that last term is rewritten using the negative exponent. So now, let's confirm that this is a perfect square trinomial to factor it. So we want to rewrite it in this form. So let's think about that the first term can be rewritten as 1/2 y cubed all squared, so a squared. And then the last term could be rewritten as 1/2 y to the negative 3 all squared. So I have a squared in the front, b squared all the way in the back, plus b squared. And so now, is the middle term equal to just 1/2? So the middle term would have to be plus 2ab. So 2 and then times 1/2 y cubed times 1/2 y to the negative 3. Well, this is going to work out nicely. 2 times 1/2, that's going to cancel and just give me 1. So I do have 1/2 left, and y cubed times y to the negative 3, we would add those exponents, and that's y to the 0, which is 1. So these are gone, and all I have left is that 1/2. So the middle here is 1/2. So this is confirmed to be a perfect square trinomial, so that means that it's going to factor to a plus b all squared. 1/2 y cubed plus 1/2 y to the negative 3 all squared. And now let's factor 1/16 e to the 2x minus 1/4 plus 1/4 e to the negative 2x. So this is going to be a perfect square trinomial. It's going to end up looking like this bottom form here since the middle term is negative. Let's confirm it by rewriting the first term as 1/4 e to the x all squared. And then the last term is going to be 1/2 e to the negative x all squared. So this is a squared, this is b squared. Let's confirm that the middle term is going to be minus 2ab. So minus 2a was 1/4 e to the x b was 1/2 e to the negative x. So let's just make sure that this simplifies down nicely. So 2 times 1/2 is 1. So I have 1/4 left, or minus 1/4. And e to the x times e to the negative x, those are going to become e to the 0, which is just 1. So I do have left just a negative 1/4 happening right there. So this is all negative 1/4. And so this is a perfect square trinomial that will factor to 1/4 e to the x minus 1/2 e to the negative x all squared.